Right. Yes, there we go. Okay, now we have sound. And yes, I was quickly sitting down because I was drawing. I'm terrible at drawing, and I can't draw. I won't admit it, but hey ho. Anyway. Sorry, I have to do a shot for the the preview, but hey ho. Oh, right, and let's get chat. You think I was muted, but no, not. Anyway, right. The day's getting shorter and the light's getting longer. I have no idea. Anyway, we are here to talk about university. All things educational and learning and tutoring. And yes, like you, I can't wait to get past the 2D thing. We're nearly to the end now. We are, wow, we've been, I'd say it should be 23 weeks, but as everyone who's been watching us knows, it's been 21 weeks because we had 2-parter at the beginning and we had the accidental 2-part a few weeks back. And we're nearly there. Next week should be interesting. It's going to be shaders. But anyway, so obviously we're going to go through the course. We're going through all the 2D step things, looking for all the things that I disagree with in the tutorial that would probably do differently, even though I did review it. And going on, MonoGame streaming as ever. We've got the university today every Thursday. Tomorrow is Tom's coding every Friday. He's promised to liven things up with some more funky things because he says that people don't like watching him just fix bugs, but I love watching him fix bugs because his brain works fantastically. And obviously, Dom keeps saying Dom has got the next episode scheduled up, but keeps tweaking it. Dom, just release it. Just do it. But anyway, let's get on. We are here for MonoGame. MonoGame being a C# game development framework for all game enthusiasts out there who want to just build games fun ways without any tools, engines, frameworks, things getting in the way. Let's just get on with actually building the game and build it ourselves. And in here now we're going through the 2D tutorial. And as we get on, we're scrolling down now to... It's titled Completing the Game, but it's not. I'd say this is more adding finishing touches and sort of bringing things together before we also then do the other bits. But this concludes out the whole part of my general rule of first make it work, then make it pretty. So this now completes the sort of making it work. So we've sort of half got a game there. We've got a title screen which looks okay. We've got a game screen which sort of looks okay, but there's not much in there that we need to do more. So sort of round it off and polish it off. So we need like a pause screen. We need like game over screens. We need to be able to handle all the different interactions. So this chapter sort of brings everything back together. And just for funs, we're not doing any of the talky stuff. We're just going to go straight into the code itself. So, right, where are we? So yeah, we're going to go some stuff. And this has been working well the last few weeks. So if I put this here, and we take this and we put it here, and get rid of that, and we'll dock and undock this thing as we swap things out. Let's get on, he says. And for funds, these are meeting suites today because I need the energy. For American friends, these are called suites, not candies, suites. And I'm sorry, but we have much better ones over here in the UK. My last trip to the States, where I went to see all my American contacts, I had a goodie bag with over £60 worth of Crunchies, Milky Ways, Whispers, lots of good British chocolate. I must say British, European chocolate, because we have sugar. We like sugar. And I'm delving away. So, that was a bad idea. I now can't draw. Okay. So, as part of the story in this, we're again doing some refactoring, restructuring to try and make things a bit more componentized in how we're building the game. Because yes, we've got screens, yes, we've got some engine stuff over here, but we still want to break things up and have so that we don't have everything in one place. It's good to sort of compartmentalize the code. Thanks, Kindon. Yeah, yep. The UK is it used to be a good place to live. I'm not entirely sure these days, but it's still doable. So we're breaking things down into smaller and smaller chunks so that we. We'll continue with things I said. Tell you we got pocket coffee. We need an extra bit of shot in chocolate. Oh, that sounds. Although I must admit, I'm not a fan of coffee chocolates. Although there are some things. Okay, I'm going to turn off. Everyone waiting with our sweet, fantastic things from across the world. Okay, let's get started. So we're creating this game scene UI, and we're putting it in a UI folder in our game project. Still think at some point I should be breaking this out and doing something different. Because no, we don't copy. Oh, come on, so we can get together. We don't name a file with the entire class contents. That's just wrong. All right, just put that in there. Oh, good. Nice to see the good stuff is getting out there across the world. So anyway, I digress. So in this now, we're creating a single component which is going to handle all the actual UI in the game. So our main game core code and the mechanics and how the snake works and all the business of the logic that's in there is not interfered by some of things like how the UI should draw. We have the UI drawing in one way, so we just call UI draw. And if I ever need to touch the UI, then I know where I'm going to go. I'm going to go to the game scene UI, and that's going to change that. So as we go through here now, yes, I asked Chris to put this in quite critically, because of as in some of the chapters on the code is that some is like self-contained things. In others, we're building up piece by piece. And until you get to the end, it ain't going to work or fly or run. But anyway, so we'll start off with some properties in here and walking through to see what we've got. So obviously we need to be able to control the sound. For focusing on, again, this is all the code going to relate to just our UI. So we have sound effects when the UI occurs. We got a panel for doing pausing. We got we're moving our animated buttons. We're putting in our buttons for our pause panel, the looks of it, and the retry. So okay, that's just some panel UI. Oh yeah, I didn't see that there. There's also a score format. So yeah, we're formatting scores. Text enumeration and formatting is always fun. Anyway, we've also got some events which are going to handle all the actual game click UIs, all the interactions. I always recommend using events over trying to use sort of pulling or polling or looking for something, because you're creating a hard dependency when you're connecting your code together. Invariably, what you want is sort of a decoupled logic of Spaceman says, hey, and someone else is listening to Spaceman and goes, oh, you said hey, right, I'll say hey back. And anyone else who's not listening to the Spaceman doesn't respond because they didn't hear him say it. The same as with UIs, case of like a health event occurs, an interaction happens, or something goes on. You separate out from what the shout is and what you're saying from who's listening and who's going to respond and do something with it. If you're constantly looking at a part of the screen and going here, there, you might be updating things probably too frequently, so you don't need to. And also, it actually locks you off, because if you don't use like events for doing these things, then if you wanted like a countdown animation or some kind of fading effect, then if you're constantly pushing it, then you have to put additional logic in to handle when it's being pushed or not, and nothing else. An event just makes that simpler, because you'd have you might have like a constantly degrading health bar, for instance, for whatever reason. And that health bar is then increased when you go over a specific piece of stuff, like a health potion or a health tracker, things like that. I'm going to game ideas now. Should be writing this down. And so the health bar should, in itself, it always is constantly going down. And then when it gets an event of some health coming in, it's like event, right, okay, just top it up. But you can control all that because you know exactly when it's going to happen. If my code's going, my health is here, my health is here, my health is here, my health is here, you have to account for that and then check it. Is it changed? Is it not? Is it? Events just make that simpler. Uh-huh. So here we go. Effectively, events are just the buttons like are on the pause panel. So we're either going to resume. So if we're not dead, we can have resume and quit. If you are dead, then it's retry and quit in our pause screen. And so then we want a constructor in here. Oh, look, there's our red squiggles, and it doesn't work anymore. Code is compiling. No, it comes later. And it says, so obviously, like anything else, a case of like where this is this is all based on a GUM container. So we're building GUM UI within UI and just calling it from UI. Why not? So obviously, following the the GUM rules, okay, so like we have to set the docking method for how the screen's going to fit. We're adding it to the content root, and then also wiring up the content manager, loading in our sound effects. We can do this in the constructor here because, yeah, this isn't the game constructor. This is something we're going to construct later on, probably in low content. Hey, Dato Kudai. Hi there. And welcome. And then we're going to wire up all our bits of things within the screen and then add them here. So we're creating it, now we're adding it. And I really should try and get some more sleep. Okay, so then we've got all UI bits. So we're going to have the score that's going to be on the screen. So here we're creating a nice little, we've already done this in previous weeks when we were setting this up, but we're just breaking it up now so it's a bit more contained. So the score that's going to be written on the screen using GUM, it's going to be a quick text runtime. We're going to dock it into the top left-hand corner of the screen, up by there. Where's your left? There's your left. Why am I reversed? The camera must be reversed. So your top left. Yeah. And then we're setting up this relationship, and then we're also, this is where the formatting is coming in. So we're taking the format, which is what we defined up here, which simply says score, a number, and it's going to be a maximum of 6 characters. So if it goes over, then it won't work, it won't break. Again, using the GUM FNT file is not a true text file. Remember, if you remember looking back at the UI week, the week when we did UI, we're not using true type fonts. We're using the specific font format that GUM uses. Maybe GUM will change that in the future. Who knows, Vic? So we want the scores, so it's going to be print on the screen. Then we want our pause panel, creating that nice and quickly. And in here again, exactly the same now. So we're creating a panel that's centered to the screen. Just draw it here. We're getting the back, whoops. Where we go? There we go. We're getting the background from our atlas, which we've already previously loaded. And then we're doing a nice, we're basically drawing the background using nice size, so it's probably tiles. We got some text for it's paused. Set our buttons up. Why is that saying? No, I don't want to simplify it. Go. Oh, we haven't turned that off, have we? Oh, where are we? Oh, that was close. Go away. Sleep for eternity. Then we're going to wire up our events for our button clicks. We have an additional one here for a focus. So because this is an animated button, then when we get focus, we want to animate and do something. And then we've also got our quit button. Lots of things. And then we've got the game over panel, which is pretty much the same as the pause panels. So we can reuse. The good thing about componentization, the way you're doing this, is that even though I've got 2 distinct panels, you notice that the quit button used the same event. So both quit buttons use the same event. So I'm not duplicating code. I'm just reusing UI that's going to be on the screen. I mean, you could make this simpler by making this into its own little method to say, give me a quit button. In fact, you could almost argue that these, no, that one. Yeah, creating these buttons could also be componentized, but let's not go overkill, go overboard. It's just we have our buttons when they're working, they're simplified, we get them in. And right, where are we up to now? Okay, then we got our event handlers. So there's our buttons. We obviously then need to have to handle when these things click. And again, this is where events really come into play, because you're not constantly going, unlike the input system in MonoGame, and we have talked about this in the open hours a few times now, is that MonoGames, the way input is handled in MonoGame is inherent from the way XNA did it. And then XNA does what's called a polling system, where it's going, have I pressed, have I pressed, have I pressed, have I pressed, constantly. And if that state changes, it's going, I've pressed, I've pressed, I've pressed, I've pressed, and filters it down. But the problem with that is that it is actually possible to lose an input. So from the point it happened to the point you told about it, you could skip a frame and not actually get the input in that same frame, which is a problem. It's a problem in itself. And the way that a lot of the more modern frameworks, or even Unity, works this way is that the input system works off events. So it uses the hardware logic for when it's listening to the hardware of saying when something's happened. And rather than just checking, have you pressed, have you pressed, have you pressed, it goes, tell me when you pressed. Then the frame that input is changed, you get an event, and you have an event-based system where you go, right, this key's been pressed. The keyboard state's changed. This is what it is now, rather than having to keep checking it and polling it every single frame. And this is what we do with buttons, or how GUM at least handles with button clicks, is that underneath it's being polled by all the XNA events, but to the outside world, it's a case of, right, I've clicked, I've got focus. It's a lot simpler, a lot easier to handle, and there's a lot less happening above the layer of the effect of the hardware when things are happening. The hardware always needs to be there checking, polling constantly in case if it has anything changed. But then to the upside world, it's all events, because a button has pressed, a button is being held. You only need to know when it happens. And it's arguably, it's one of the things we're looking to potentially change in the future. I've not yawned all day, and now I'm yawning. What is with that? So I just scroll past that then. There we go. So we were talking about event handlers. We're not actually implementing them. So let's see, several events here. So obviously when the resume button's clicked, we want something to happen. When the retry button clicked, so both, they play the UI sound effect. And if you might see this logic sometimes in code, in case of like, is an event null? What that is actually really saying is anyone listening? If no one's listening, don't tell anyone. If you've used Unity or something else, well, you probably see something like that. Oh, no, you can spell right. And you'll see this null parameter is actually put in to simply say, if there is anyone listening, then tell them about it. If no one's listening, don't bother. And it skips over. And the compiler's clever enough to know in the case of, like, at this point in time when the code is running, is anyone listening? And the null check simply goes, yeah. So if you see this, that's why. It's a simple catch-all of, do I need to do anything? Really? Yeah, really? No. So then we got a quit button, and element got focus. So then we can actually play our sound effect. We're doing sound effects all over the place. What's going on here? Oh, I do apologize. Every week. I'm staring at my sweets now. I've also got some of these. I've got some snakes. These are really tasty. Mostly gummy and sweet things. I've got some bars over there. Need energy. I must need energy because I'm yawning. Right, okay, so when you come to look at this now, public and private is an interesting concept. Now, most of experienced developers know this, and it's things. But I even talked to my son who's studying computer science, Hey, Turtle, we still don't have the graphic. You must provide a graphic, he says. We can have an overlay. We can do funky things. We need a turtle overlay. It's like we've got. See, I've got rain. I've got snow. I've got stars. I've got some funky background things. We need one for what on earth is that? Thank you. I didn't even know that one existed. What's this one? Oh, breaking news! Breaking news. Simon is yawning because he's tired. Yeah, we need an overlay for a turtle. Chris, he's still on the game. Not many weeks left. The 2D tutorial to use it either. Anyway. Yeah, so I was talking about this with someone who's studying sort of computer science at college level now, and they come out the whole point about object-oriented programming or logic around the scene. So invariably, any class or function you create, you want it to make sure the fact that it's operating only internally and what it's doing. So it's managing all its states and everything else. Only when you need the outside people to pass things from the outside, do you then go and create some like public functions like these to do something. Now, hopefully the lazy programmer, they might make everything public, but therein lies a danger. Okay, so if you can't control what happens inside a class, then any part of your game could inadvertently change the state of something. For instance, so like, if the panel is visible, I could accidentally type in some other piece of functionality. Oh, in this class, go make it visible. And then you'll spend half an hour trying to figure out why on earth the pause screen is coming up every time your slime eats the bat. I've forgotten the name of it. Slime eats a bat, the pause screen comes up and then goes away. And you're like, why does that keep happening? And you'll spend ages digging around. But if you make sure the case of everything that happens within a class is private and it's just that class working on it, great. And only make it public if you need something to happen. And even then, when it's public, you control what happens inside the class. It's sort of like, other drivers can't make your car turn left. Someone can say, a policeman can come up and rap on the window and go, turn left. And you go, okay, but you're the one doing the turning, not the officer, unless he's doing a pit maneuver. I know. I speak Python, not English. Yeah, it's no compom. No. That's my pitching French. Anyway, so we're doing the same here. Is case we're having lots of functions. So if we need to update the score, we're not having code update the score itself. We're saying this is a value I need you to change the score by. It goes and formats the text that's going to draw and it gets updated. If we're going to show the panel, this is what happens when it's showing. Hide, show game over. And obviously, we want to draw. Chat's going wild on speaking languages. It's just a good day. Okay, so we've now got one class now, and we should have no code errors in here at all. Yep, no errors. We do have one late. This is my pet peeve. Empty space. If you see one of my PRs, I'm cleaning up empty spaces. So here we now got one class which is going to handle all of the code UI that's running within our game. So now we need to go back into our game and strip out anything that's not related to this. So we're going back to our game scene. In fact, I left this window up and I don't need it. So let's go to our game scene. Because we've got loads of stuff here to handle all different things. Now we need to use our separate UI class instead. Oh, look at this. Are we starting from fresh? We're starting fresh. This is brave. See my game? There. Now try and run it. Oh dear. Next I'll be dropping into Red Dwarf and doing a bit of I actually looking back at 80 shows and some of the character names you got I've forgotten character names. Got Crichton, got Cat, Lister, and then we have Rimmer. Arnold J. Rimmer. And in today's day and age, you think, really? Anyway, so we're starting off now. We've really trimmed down now what is an arcade. Again, this is something you should always aim for. Your actual main game functionality itself should be just like orchestration. It's a case of it's managing all the trains on the tracks. It's not doing the actual running of the train. The trains run themselves. We do the same thing with our game itself. We set up what we need, and then we tell it to go off and do something. So in here now we've reduced it down to, we know where slime is, we know where the bat is, we're controlling those. We're knowing the size of our screen and what the tiles are we're using. And also we know we track the score from a global perspective, so we can tell the UI this is what the score is. And then obviously now we've got our new game scene UI, which handles the game UI. And what is our game doing? What state are we in? I like state-driven development. It's good. So then we can then simplify our initializing phase. So now when our game's loading, it's a case of we're just setting the stage, but just the bits we need. So setting up how, so we're, can we escape from here? Can we set up the room bound? So in our drawing of game, we're actually going to control the size. We're winding up the collision. So now the slime's going to be going and it'll go, I've collided with something. And then we're going to handle it in the game of saying, right, well, this is what you should do. We're initializing our gum. We're getting gum ready. Then we're going to initialize the UI and initialize a new game. So initialize UI again. Now, before this was a huge, horrendous class. We're doing lots of drawing. Now we're simply going to say, create some game UI. All that code now has been moved off into its own thing. The UI handles itself. We don't need to worry about it. We're just worrying about the game itself. UI, be damned, off it goes. But we're still listening. But here you can see we're actually winding up to the events. So if resumed clicked, the game can continue. If we tries click, the game continue, but it's restarting everything else. And if we're quitting, we're out of here. Just go. You don't belong here. Then we can wire up the handlers. So again, in the role of orchestration and managing our game, so if I'm resume click, then I'm going to change the state of my game from paused to play and just continue where we're going. If we're going to retry, we're going to start a new game. And if we're quitting, we're going out to the title screen. In modern day and age, and I do like this, you have a quit and you have a really quit, which is just chop the head off this beast, throw it on the floor, we're out of here. I don't want to see no title screen again, unless it's like Dead Space or something, which has a really cool intro screen. I love it with the 3D effect. But anyway, if we're starting a new game, then effectively we're setting everything up. Obviously, we're going to use this all the time. So when the first game starts, we're starting a new game. If we're retrying, we're starting a new game, but we're doing the same thing. But this follows the pattern of keeping code simple. Instead of like having code here and here, which is the same thing, if you have something that needs to be done, you compartmentalize it, put it into its own function, and that is what's responsible for it. I've harped up in previous weeks about the sort of single source of responsibility. If there's a job that's needed doing, make one thing that does that job and make it do it well. And nothing else should get interfering or worrying about it. So here, this is refactoring around what we had in some of the original code of we're setting up where the slime's going to start. We're going to initialize the slime and say, right, you're here. This is where you are. Off you go. We're then going to randomize where the bat is, because obviously that randomized functionality got moved into the bat itself as well. So the bat's responsible for where the bat goes and where it randomly spawns. And then also a quick check of saying, right, bat, slime, you can't be in the same place at the same time when we begin. If it happens later, then all bets are off. So as we're initializing, and then we're using this now, we're using states to drive how our game runs and also control whether input's handled, whether things are drawing on the screen or what's shown on the screen. It's only depending on which state you're in. This is very useful, especially if you're going to look at having transitions between different levels of games and things. You have a state of transitioning, so that at that point you're doing a screen wipe from one screen to another because you're moving from one level to level 2 somewhere else or beyond. Low content, obviously this is something that generally is managed within the game itself. Again, this is something you arguably can move off depending on what it is. So you might tell the slime, so here's the content manager, you go and load yourself. Mr. Bat, off you go. But in this case, we're using a central atlas to be able to load everything else. So it makes sense to have the game itself running or managing what content's going to be loading. So then okay. Now we went and deleted that code. This is using the old way of doing it. Whoops. But I've just deleted all the code. What are we going to do? I could undo and do everything, but no. This is another good lesson of we use source control. If you look back at previous weeks, source control is a good way of basically having track changes on your code. You want to know what it looked like before. This keeps a track of it. And so as you're making changes in the game, you reach a good checkpoint. You're effectively saving it, bundle it, and it goes into actual commit. So now I can say, wow, what did this game scene class look like before? So we'll go back to our UI. There's our game scene. And here you can see this is the game scene as it was, and this is what I did to it. Shows me all the changes. Now, if I go down to here to my load content, yes, see, I was doing things very different because I'm loading the XML because if you recall back in, where were we? When did I start messing with this? I think it was chapter 6 or 7. If you look back at that week, is that the tutorial does one thing I hate, which is loading configuration at runtime. It's a bad idea. It's just not good. Just don't do it. What you should do is you push the loading the content back into the content pipeline. So there you can validate, make sure the configuration is correctly, make sure the content's there. If you're like a tile map and you're loading up content and assets from somewhere else, do those exist before your game runs. Once your game runs, you've got to handle that at runtime. And if something's wrong, boom. I have seen tens of games do this, and they've shipped a fix out, and the instant the game runs, even though it ran fine in QA and test, because they still had the files on the machine locally when it was being tested. When they shipped, those things didn't exist, and the game went boom. And then you're talking either usually between 4 hours and a week to push a release out, depending on who you're using. For instance, I've known Apple take minutes, and I've seen Apple take a week because they felt like it. Imagine if your game's not playable for a week. So, even with all the best tests in the world, even with QA and everything else, unless they're clearing down the machines every single time and testing just the pure release, some houses do, test your content early. And this is what we did. We converted up this now so that let's go back from there. Let's have a look further back in time. What did my game scene look back here? So see this, and this is the beauty of source control. I can go all the way back to down here. Let's see, look, we added the library. No, that's our game class when we did it. In fact, look, and so I can probably see here down chapter 7. Yeah, there it is, trashless data, and in our game, we changed from using the old way to there is our old way. Yeah, see, you can see here, we've got texture atlas from file, but we're loading it from atlas data. And the atlas data was a content file, which loaded in fact from there. So let's see now here, our game class. Nope, game scene class. So okay, yeah. So we need to add these things in. We needed the atlas data. But we'll take both. We'll take both of these. And we'll probably find things break as we go. Interesting. That's in a different using space. There we go. Go back to our. No. Where it is? There it is. Oh, we might not need atlas data. Oh, that's a good point. We need to double check that in the actual system. There's load content. Initialize. Pause. There it is. So yeah, we need you. Probably need both. Arguably, we need both. Oh yes, we made it into. Yeah, in the UI phase, we had to actually load the Atlas Navigate reference because the UI used it. So the question is then, why is the UI not using it now? So not you. That's probably going to break something else. So yes, that's going to break you. It's going to break you. And now let's double check now. What Atlas is our game scene UI using? Did we miss a trick here? Yes. Whoa. In our refactored game scene code, yeah, that was going to fail because that doesn't exist. So, realistically speaking, so this has got In fact, I can argue, yeah, we're loading the Atlas. We shouldn't be loading it multiple times, even though because effectively putting it into there or putting it into another screen, it means that we're multiple loading content or else. Now, I can either duplicate code. When's the first time this is used? Atlas. It's used by everything. So we need it here. So do it properly or do it right. Neither's available. Cursor and cursor now. That's coming from GUM. Let's look because that's the content manager. I mean, granted, now this is an interesting point of debate here now because the content manager itself is very memory efficient. So once you load something from disk and it goes into memory for the content manager and then it's delivered to your game as a reference, if you load it again, it doesn't load it from disk again, it's loaded from memory. So tell you what, let's not overthink this. And we'd probably be able to just get away with taking this on the game. We're not even getting the game scene, but no, because we still need the Atlas for the game. So we'll see what we get to anyway. So even though it might appear, nope. And we need to use this one. And we need to have a reference. And then our Atlas. What was that? Order this the right way. Do it the right way around, or else it will not work. And Atlas then is from there. No, it's not quite. It's to that. Let's update this comment properly from the XML content file. So we're not losing it. I mean, yes, we're technically duplicating code, and I don't like duplicating code. And yeah, well, I could spend 20 minutes trying to refactor this into the way I would like it, or we can just make it work. So yeah, so our game scene UI now is loading our Atlas data from content pipeline. Oh, take that back! I have to use Unity for my day job. Don't bring Unity in my MonoGame. It's only similar because it's all C#. So Unity uses C# in the background. MonoGame uses C# in the background. So it's all very similar, except there's a lot of things which are available. Do not get me started on the Unity asset pipeline. Oh, you'll have a rant for half an hour of me about the Unity asset pipeline. Right, now we have actually added this here, but in all likelihood, we'll see. If at any point we need to use Atlas data in this class anymore, because again, this is restructure everything around now, so it puts it where it needs to be, but we do know that we need to use the Atlas for drawing the game background. It's half floor. But let's see where we get to. So, yeah, no, that bad. We're not doing that. So, oh yes, we still, yeah, while I, yes, upgraded the Techno Atlas, I then didn't go. I should retroactively, for this tutorial, go back and fix this. But yeah, the tile map, that's true, it's the tile map. The tile map does use the Atlas. Because this definition, so this tile definition is just this. It's got, get away from our source control now. If we look at our content, image, why is it doing? I question my sanity at times. So this, the tile map, if you recall back from chapter 13. So this is just saying what part of the Texture Atlas to use. Thank you, Chris. What tile to draw where. So yes, we're still using that. I should have updated this to use the content pipeline. I was lazy and didn't. Should be. So again, I even though that's there, you can go away and do it if you wish. Hey, Chris, don't get me started on MonoGame extended on content pipeline. Stop blaming us. Okay, so anyway, so we're going to create our animated slime as slime animation, animated sprite for the slime. Oh yeah, we are using that, so we do need to load it because we do need to for here anyway. And then we're going to create the bat animation, and we're going to create our sound effects and create our bat and our collection tune. So right, fine. So that's all fine now. Load content's good, and it will work because I removed code, which would prevent it from working. Okay, then again, keeping update as simple as possible now. So before, where the whole update loop was done, this, and this, and this. Ah, look at that. See, we changed this. Back in the input manager, we paused. Why is did I not call it pause? Yes, we also went and changed the input manager to put it all in one place. Where are we? So down in our library, in our input manager, what was pause? Oh, pause pressed. So in here, I've got all the state code, and then I've got all the action code, which does things in one place, where some people just like multiple classes to do the same thing. Yeah. I digress. I have fun. Okay, so again, the update is now simple because all we're going to do is, if it's game over, man, game over. We stop doing anything. Also, if we pause, then we're going to toggle pause, and obviously then, if we are paused, no updates. If we're running, so if our game state's not paused, if it's not game over, we go and update the slime, we go update the bat, and then we're just checking, are these two very close friends? And do we need to handle that? So then we bring back our collision code. So arguably, yes, you could have it so the slime predominantly checks all its collisions, but it's simpler in this way just to actually just do it all in one go, where is slime hitting bat? Is slime hitting the wall? And is the bat hitting the wall? So yeah, arguably, yeah, the bat collisions we could obviously move into the bat class because it just needs to handle what it's doing. The slime interacting with the bat, we could have simply patted the bat each frame and then work it out, but then we also need to reference the bat and there. And also then if the slime is hitting the wall. But we're compacting things, keeping things simple, so it's just doing very simple things. All collision code now happens in one place. Wow, we are running to time. Interesting. So then we need an obviously quick check of make sure slime and bat are not close to each other. And again, this just refactor around the logic we had in place, which was in a few different places of the code. So we get the bounds for the slime. We get the I'll wake up one day. We get the bounds for the bat, and then we're just going to do some simple checks to say if I move the bat here, are they colliding, and what to do with it. And then basically give the bat a new position, off it goes, off it runs. Okay, then we need to go and handle all those events coming from our pesky UI. So while your UI is doing all these events for, have I pressed something, have I clicked a button, have I exited, and then we just got the simple event here then of why is that there? That is not, oh, it's okay, class as an event handler. So as the slime collided with the bat, it's game over. Have we hit pause? So when we hit pause, are we currently paused? Then we're unpausing. It's amazing how millions of times I've actually written the code to do the same thing, and you always think there must be a simple way of doing this, but no. And then if we go over, show the panel, and game over. And then last but not least, we're going to draw. So core part of anything is, again, because we've removed and refactored a lot of the code around for what needs to happen where. Drawing is simple. We're just going to say, clear the screen, start a new batch, draw my tiles, draw my slime, draw my bat. Again, the order is important because each draw call draws from the back to the front, one on top of the other. Call end, and then once we've finished drawing all our game stuff, we then draw the UI on top of it. Couldn't be simpler. Now, once we've got that, so that's got the game running, but there's one small little issue, is that we can pause the game. That's all we can do because we have no game code. So one thing we talked about back in the input class is adding input buffering. So this makes it so that it handles better how many key presses you're pressing and how the handle in each frames. And this stops the case of that the problem of trying to fight with the keyboard when we're trying to do input, to keep things simple. So what we're doing here, okay, we're going to add the system lock link class. Now we're probably going to have to mess with the input code because we have messed with input a lot within this game, at least in the update game. Okay, so we're basically setting a queue now for how many keys we can press within a single frame. I'm going to type and then I'm going to go way. I missed that because queues in a different namespace. System collections, but we did not. Oh, it's already there. Interesting. No. That's a bug. I say we like finding bugs, but we don't. So in the slime class, we're going to add a new locate the initialize method in slime. So where's our slime? Slime was a game object. There's our slime, and where's our? Oh yes, no, we have got input and control because now that we moved all the input handling into the actual thing, so keyboard inputs and things are all handled by the slime, so the game doesn't need to do it. Job's a good one. So where's our initialize method? Initialize. And we're going to have we're going to set up. In fact, okay, so if I've done that I've done it in the wrong place. I've put in the game scene. Right, okay, so let's take those out and take that out because we did it wrong. No one stopped me. And because I didn't read it, we don't in the slime class. Come on, stream, get together. So yes, there we are. There's collection. So now, yes, now we want to do okay. Link. And then we also need to go and add. Okay, we missed it now. We're going to add our two properties. This in the slime because this is the input. We're doing input handling with the slime itself, of course. Okay, so in initialize, we need to do a new input buffer. We've created the buffer. We're going to initialize and have it ready. Always very important. Make sure you initialize before you run. If you don't, you'll fall over. Okay, then all we're going to do then is rationalize around. Okay, no. Potential next direction. That's already in there. So, oh, I see. Okay, so we're initializing it. No one can stop me. I'm on the stream and I'm doing what I like. And no one can stop me. Okay, so instead of going for the next direction, okay, we're actually initializing to vector 2.0. So starting with no input, and then we do all the manipulations of case of what input's being received. And then we're going to handle this then once we've got all the inputs and how they happen. We're right. And we are, right, that's not there anymore, so I'm going to trust it and see what happens. So if we have, so in other words, okay, so if we have pressed a key, so our input is not 0, and we've got our input buffer is not full. Interesting. We're going to validate the input, and then we're going to queue up what the input happens. Now, what this is separating out is from the key press to the event that's going to happen. So rather than just changing direction straight away, we're going to queue up and say, right, this direction change has been requested. And for every key press you do, it's going to queue up to a maximum of 2. So up to 2 inputs will be received. And then we'll look at the queue and pull it out when we actually want to handle it. So now we've worked out the potential for where we want to move based upon what keys were pressed. Rather than just directly reacting to it now, is we're going to go into the move queue here, and we say, right, what is the next movement? Now, this is crucial because now you can't get any confusion about what the inputs coming in or have inputs overriding each other, no matter what keys and how much you bash the keyboard or how many keys return each frame. I'm only going to have one. We're simply going to say, right, what is the next movement I'm going to do for this frame? And then run it. So this now decouples between what the keyboard input's doing and what the game will do and react to, which is quite useful. But again, this is one of those things where you only do this if you're having issues. If your input's working fine and there's no problems, you probably don't need to. But this is a nice, good preventive measure of separating out from what the input is and however much people are bashing on the keyboard to what your game receives and what it enacts on, and ensuring that there's a steady flow of information of what it's actually doing. So according to this now, my game should apparently run. We shall see. Where are we? Desktop GL. Start new instance. Oh, the demo goods with us today. I'll be running and going to click and collect. We shall see. Now it still comes over onto this other screen. Oh, there we go. I didn't go and fix all the. I didn't take the things out. Okay, we've got start options. Fine. So that's the title screen. We haven't worked on that today. We've only worked on the actual game. So we're going to the game. Oh, darn it. And there we go. So the game scene UI is handling the score. So all 6 characters that you can have on the score. We've got, why only 6 characters? What if I want to have 1 million? What if I collect 1 million bats? Will my game then? No, I'll just go to 0. Anyway, okay, we try. Can we do this? Can I survive the music long enough? Actually, this is actually quite. There we go. So we can see now the slime is controlling its movement as so the input. And no matter how much I mash this keyboard now, my input is protected. Come back here. How does anyone play this game? Oh, there we go. There we go. The rest of the stream, I'm just going to play Dungeon Slime. No, okay, let's die. We can quit. So, there we go. Everything's working now. We've got compartmentalized out now. We've taken our game class now, which was loads of code. Anything to do with the slime is in the slime class and it manages itself. Anything to do with the bat, apart from collisions, is within the bat. So the game itself now is much simpler, much more streamlined. Allows me to move around code. In some cases, I would probably refactor some things. That is an interesting point, Chris. Yeah. In fact, by that same argument, then you couldn't have 100,000 slimes on the screen either. So 6 is probably a bit adventurous. Okay, so most of the lesson I'm going to try and pull things that make them cleaner is that this is about refactoring code down to its simplest function. is having a single source of responsibility for doing something. So all the UI code is now in its own class for the game, and the game only needs to worry about things that happen outside or interactions between different objects in the game, reducing the amount of complexity in here of what we need to do. So knowing that how I'm going to set up a game board, you can almost argue you might actually set up a separate class as well for a game board, and it would handle drawing of the tile, the background, the tiles. It would handle about where the position of objects on the screen to again reduce this down even simpler. But you go down as far as you need to, and not one hair below. Although I can't really speak to that because I am endlessly refactoring code to no end. Testing our knowledge. How does having game states help things? Because if you need something to happen on a screen and only one thing to happen on the scene, you need a state to say, this is what I'm at, do this. This is what I'm at, do this, and so on. If you need to handle multiple states, you can handle it. But if you don't have states, you're state free. It's not stateless. Why is it important to position? Because if the back starts where the slime is, you grow by one instantly, and then you're stuck. Player 1 versus player 2. There was an interesting one of the bounties was actually multiplayer to the slime things, which didn't go well. What does input buffering solve? It stops us getting button mashing. Anyway, that's enough. Oh, look at that next week. Shaders. And more from the shaders is even more shaders. So yes, we should be releasing at this rate, we'll be releasing the 2D shader tutorial at the same time we release 385 along with the 385 samples. So that should be fun. But anyway, thanks everyone for watching. So if you're on the tubes, give us all a like and subscribe and help grow the channel. If you're on the Twitches, then hit that bell, give us a like and follow. Everything helps. Let's see, are we hitting chat? Okay. Yes, shaders. Shaders, interestingly, I've always been my nemesis through my career of game development. I understand the math, I can read the math. I can't write them, save my life, but hey ho. But with shaders, you can do funky things. Now, where you really get into real funky nature with shaders is altering how the screen renders without changing your game code. And while with the next chapter in this, which just to show one basic shader to make effectively remove the saturation at a particular point in the game, the 2D shader tutorial. I'll get asleep one of these days. The 2D shader goes to more. Look at this. We can look. Let's go back here. Let's do a sneak peek. For those of you who sponsor, that's not going to work. For those of you who sponsor MonoGame, we appreciate and love you. Oh, look at that. We have our private sponsors area, which for any tier from Sprite Batch and above, you get full access to this and early access to everything, including the advanced 2D shaders tutorial. And yes, I'm working on the 3D one. And this covers lots of funky things like having hot reload shaders, which is great for shader design. You can make tweaks, see the effects straight away. But we're doing through 5 effects, so we have transitions. I'm looking forward to getting onto this. So there are 5 transitions to go through. We have a color swapped effect where we can actually, again, I'm not changing the art of my game, not what we're doing, but I can say, well, all the colors of my game are now this. And you can actually have basically a atlas which says, if you see this color, it's now this color. We do it through a shader. No change your game or change my art assets. Funky for different biomes and levels. This is one of my funkiest things. Sprite effects. Making the 2D 3D. And then we go on and do some lights, so we can have lighting effects in the scene, do some shadows. This is by far one of the ones that we had the most trouble going through, having lights on the walls, casting shadows, and the shadows from the thing going down. Anyway, that's the private site. Sneak peeks. Shh, don't look. So, Wow, we've run to time. I did not think we've run to time. Maybe it's me. I need to go back to, let's see, what we've got now. I've got Jellyman. Or Jellyman. I don't know why they're holding hands. I shall separate them and I shall eat you separately. As we do. Okay, so thanks everyone for watching. This has been your week of university. Apart from Chris making complaints about not having too many slimes on screen. Yes. Okay, thanks everyone for watching. We shall catch you next week for some shaders. This is a good point, actually. Yes. So next week we're having shaders. Then we will have a week's break because I won't be here. I'm leaving the country. I've had enough. I'm away for a week, so we'll have no show on the. Which week will that be? Oh, well, we know. Well, I might. No, I'm definitely away. So yeah, the week of the 9th of April, I'm not going to be here. I'm going to be gone. But I've still got kids watching. The one real good thing about being a grown-up adult and having grown-up kids is that if you can go holiday, they stay home. Kids watching the house when they do. Anyway, I digress. Thanks everyone for joining, and we shall catch you all next week. And happy game building.